Welcome, everybody. I'm John Rodriquez here with Fluid-Aire Dynamics. I'm one of the inside sales for service here in Chicago. And by my side, I have Mickey Bartlett, our senior technical advisor. FYI, he's actually forgotten more than I could ever learn in my life. How long have you been at this again, Mickey?
Oh, many decades, let's put it that way.
That being said, we're here just to go over what would be how to design your perfect compressed air system. All right, and keep in mind, everybody, this may vary for your actual use, but this is just to be able to give you an idea. All right, before we get started, let's go ahead and take a quick poll and find out, why are you attending today? Just a few more seconds, and here we go. So you guys, most of you joined to learn more. Sorry, it's a small screen. Let's see here. So, all right, that's good because you definitely will learn more. If you have any questions, go ahead and write them either in the chat or the QA, and we'll get to them at the end. All right, so I already have my compressed air, right? Air is free, so compressed air should be right around the same lines, right?
Compressed air is not free. To give you an idea, it will take 8 horsepower at an electric motor to generate 1 horsepower compressed air. So the initial conversion is very, very expensive. As you see at the bottom, that the graphic is 8 horsepower to make 1 horsepower compressed air. The cost of running an air compressor or buying a compressor and its cost during its life is shown in the pie chart here. Your initial cost of the compressor is about 18% of your overall life of that machine. Maintenance costs run about 7%. Installation costs about 2%. And the biggest cost is energy. And depending on the kind of compressor you've got, the energy costs could vary greatly. One of the ways to reduce energy is to reduce waste, energy, compressed air waste. Compressed air waste could be an open blowgun someplace, blowguns without vortex nozzles on the end of them. And vortex nozzle actually will use about 10% compressed air and then draw ambient compressor across it. Also, if you're going to clean the floor with compressed air, go get a broom. Okay, it's a very expensive thing. There are other wastes within the leaks, for example, in your piping. Leaks, not necessarily in your piping, that doesn't happen very often. It's usually the connection that comes from the piping to the end use where you have your leakage. So try to keep those under control. And if you can do that, you will save a lot of energy costs. There are other ways of saving energy, however. The type of compressor I just mentioned earlier. If you have a fixed speed machine, for example, if you had a modulation air compressor, which is one that stays at a given pressure and flow through the machine changes, you can be at 50% load and still be using 85 to 87% of your energy. And when you, even in a load-unload compressor, at the unload point, it's using somewhere near 30% of its energy. So that is as you save wasted energy or save compressed air costs or usage, excuse me, you will find that the compressor you have makes a big difference on how much energy you'll save. So the current rule of thumb now is to try to get people to use VSD compressors. Power companies are asking you to go in that direction. And to be honest with you, you will save a lot of money with the VSD. The VSD will only basically use the amount of energy that it takes to make the amount of compressed air that you're using. It changes the motor speed, which changes the actual energy costs. So VSD compressors are the current rage as far as air compressors are concerned.
I mean, you can see in the chart, it says 73% is energy cost. Of that, you can see roughly 35% is wasted energy. So if you lower that, that also lowers your monthly bill and your costs. So right. It definitely helps. So now that we know that it's expensive, how much air do I really need?
Well, jump to the next slide and we'll talk about it. you should know what your minimum and maximum CFM needs are. It's more important to know the maximum also, because you don't know you don't want to run out of air, obviously. Minimum would be something that if you have a weak compressor, you might want to run. What you also need to know is what pressure do you need? It's important to run at the minimum pressure, the least amount of pressure that you can get your job done. Every 2 psi increase in air pressure is 1% of your overall energy. So if you are running a system at 125, where you could have run it at 100 psi, you could save 12.5% of your energy just by lowering your pressure. As far as sizing the compressor for CFM, all the manufacturers have a CFM specification along with the pressure that you needed at that CFM a point. And again, you have to look at not only the CFM that particular piece of equipment you'll use, but what are the cycle times? How many times is it used a minute or whatever in an hour? Or do they ever hit all at the same time? These are things that you have to look into. Again, there's no formula that you can go to and say, hey, I've got 6 machines, I need X. Really, different manufacturers have different CFM requirements for their machines, and even if they're 2 different CNCs, they may be using different CFM usages. How many shifts are you running? Is the second shift less than the first shift? And how much less? Again, does it represent a variable speed compressor that can handle that? Or are we really looking at maybe a couple compressors to handle the different shifts? In most cases, a VSD will handle the demand as long as that second shift is still running at least 50% capacity for the first shift. If you're looking at sizing a compressor, again, if you have a fixed speed machine, you got to be real close as best you can. Don't look out much more than 1 to 3 years, because it's hard to forecast well beyond that. And if you do try to forecast out the 5, 8 years, whatever it might be, and you miss the target, you could end up using way more energy than it would cost it would cost to buy an actual air compressor in a second machine or a more efficient machine at that point in time. Also, watch the type of air tools you use, or air tool manufacturers will come up with a CFM requirement. Matter of fact, some of the less expensive tools I use in their specifications. You could have a $100 air tool, let's say a grinder, that would use 10 CFM, let's say. If you were to buy the same grinder in a higher quality tool, let's say one that sells for $200 or $300, maybe $300 or $400, that might use 5 CFM. Well, it's not necessarily the cost of the tool that's, and not only that, by the better tool will last longer, but it's not only the cost of the tool you're looking at, but your cost of running that tool. So it uses twice the amount of air. An additional 5 CFM is at least a horsepower or so. So you have a situation here where you have to watch for inefficiencies in the pieces of equipment you're buying. Move on from there.
Yeah. So, okay, so we found out just how much we need. Do I need to dry my air? I mean, it's just air, right?
Yeah, it's just air. But when you take a number of volumes of air and squash it down to basically a smaller volume, you're adding all that water content to a smaller volume. Not only that, but by compressing it, you heat it up. And heating it up allows that hot air to retain more moisture. As you cool that air, as it goes down in your plant, or wherever it's going, it will drop out moisture because the temperature's dropping. So what we do, typical plants will use refrigeration dryers. And what a refrigeration dryer does is it drops your compressed air temperature down to about 38 to 40 degrees. At that point, it rains, and that moisture drops out and goes to a drain, and then to whatever a drain that you may have in a plant. When I talk about a drain, there's a drain on the dryer that will expel the water to to whatever other drain you're sending it to. Anyway, that air that's coming into the dryer is should be 100 degrees. However, if you have air temperatures coming in the dryer that are greater than 100 degrees, and that's what the dryer is designed for, you have to oversize the dryer to take that into account. Air compressors will, and most compressors today, will give you air temperatures 15 degrees higher than the ambient condition. That means the compressed air temperature. And dryers are designed for 100-degree inlet temperature. If you go up to 120 degrees within your inlet temperature, the dryer is 1/2 the size, meaning that it has twice the work to do to get that moisture out. So if you have a 250 CFM compressor, you cannot buy a 250 CFM dryer if you're at 120 degrees. You need a 500 CFM dryer to handle it. Now, there are correction factors on all the literature for dryers that you find in their literature when you go to purchase one. The other thing about a dryer is not only does it bring the air temperature down, but it reheats the air temperature as it goes out into the plant. That is very important because if you have 38-degree temperature of your compressed air, remember when air is compressed, it's heated. When it expands, it cools. Well, you can drop 20 degrees or even more when the air expands. So if you're sending 38 degrees out in your plant and you let it expand, you're going to have frost and ice or whatever else in your air tools or your cylinders or wherever what else you're using. The end result is that it has to be reheated. So the dryers then have a heat exchanger that on the inlet of the dryer that pre-cools the air coming in with the air going out and reheats that air going out. So what you end up doing is having maybe a 38-degree dew point with an 80 to 85-degree air temperature going out. So if the air temperature never sees 38 degrees again, you'll never see water.
So, I mean, that's all very good, and we could probably be here all day just talking about this. But moving forward, really, do we have to follow anything in particular?
Well, there's ISO ratings on a lot of equipment. I don't know if people pay attention to them, but they do. Manufacturers of various pieces of equipment give you some type of an idea how dry or how clean the air has to be. It's my opinion that make the air as clean as possible for all sorts of reasons. If you have most climates, most manufacturers use refrigerated dryers, and rightly so, because the air is not going outside or in a special environment. There are desiccant dryers, and desiccant dryers will bring you down to a -40 or -100-degree dew point for air that might be going outside of the facility into the cold environment, so you don't have frost or freezing up of valves and cylinders outside. So desiccant dryers should be used, and most likely point of use, meaning that desiccant dryer would be placed just prior to going outside and only handle the air that's being delivered outside.
So what I'm getting is, yes, you should have a dryer. Refrigerated dryers would probably be the one to go with, unless you have a specific use for a desiccant.
Right, absolutely. You'd have to want it. Anything that would go, you need dew points below 38 degrees, which is below freezing, basically.
All right. So we dried our air, and now does it have to be clean?
Yeah, and in most cases, yes. Inline filtration is something that you can play around a little bit with. I have my own opinions on how that should lay out, but I like to have the cleanest air possible going into my facility. But you can see in the graphic on the right-hand side here, there are various different elements that go into a filter housing. They're pretty much all the same price. So it's a matter of selecting the ones that will be best for you. You can see that there's a 3-micron particle filter. That'll take out basically the cats and dogs. There's also a 1-micron filter, which is a little bit better. And not only that, but that'll take out a little bit of oil. Now these filters, all these oil filters will also take out any moisture that's available at that point. Then you can go into a high efficiency filter, which will take out a lot of the oil and get you down to 0.01 micron. Now 0.01 micron is pretty small, And so if you didn't have one of those two filters prior to that, either the 3 micron or the 1 micron filter, you would load that up pretty quickly. So it is advisable to have one of those filters, either one of those filters prior to the 0.01 micron. Now the amount of oil retained after still in the airline after the 0.01 micron is relatively low. But if you really need to be down to hardly any hydrocarbons, you can put a charcoal filter in. Charcoal filters will absorb not only oil, but oil vapor and also smell. So it would bring you down to a 0.003 ppm, which is virtually oil free. Problem with charcoal filters is there's no indicator of when they're used up. So you have to get a kind of a feeling for how much air that you've ran through that filter, how long it will last. And generally speaking, all the filters need to be changed once a year. The charcoal filter could be changed as much as once a quarter. And maybe even more often than that if there's a lot of oil in the line. That's why you have those other filters previous to that, so there isn't that much oil.
It all depends on what they're doing.
It all depends on what you're doing, but as I said, my standard would be a 3 micron prior to a refrigerated dryer, a 0.01 micron after it, and to just general terms, and that gives you clean enough air to run just almost any manufacturing facility.
Good. So now that we've figured out that we have to clean it, we have to dry it, how do we get it from the compressor to our equipment?
Well, it's there's a lot of variations of this, but we decided to put this one up. And what it basically is we have an air compressor there that has an aftercooler on it. The aftercooler on the air compressor takes about 70% of the moisture out of the air. But once it leaves that aftercooler, the air is saturated. And we do have a drain there where we'll drain the water out at that point. And then it goes on, and typically the best situation is to have 2 tanks, a wet tank and a dry tank. When you get to the wet tank is another a trap basically for moisture. Not only that, but the area of the tank and the compressed air inside of it has a chance to cool down further. And the reason you do that, a couple of reasons you do that is if there's any problem with the drain prior to the compressor, or if there's actually to cool down the air a little bit further so the dryer doesn't have as big a burden. The other thing is that if you have any moisture in your line and you run moisture into a refrigerated dryer, meaning liquid water, the dryer is designed to take out humidity. If you send liquid water into it, it becomes a water chiller. So you do not want liquid water entering the dryer. It won't do its job. And from the dryer, we drain more moisture out, okay? And again, we have a pre-filter here to protect the dryer from any contaminants.
This would be that particular filter.
Right, particulate filter, one of the 2 that we mentioned earlier, yes. And then from that, we'll go to the 0.01 micron that I mentioned also. And that filter, again, all these have drains. And then you go to your dry tank, which is basically your battery or your storage area. And that is sized, and we can get into that in a different subject later on, but the size of your tank is, we need a lot of calculations to come up with whether it's the right size tank for you, but we can handle that for you if you want to give us a ring. Also, all those condensation lines are leading to what's called an oil water separator. The EPA doesn't like you throwing oil down the drain. So what this does is it separates the oil from the water, sends clearing water down the drain and collects oil into a canister of some sort. Now let's talk about the loop itself. When you go into your main, you're going to go into that. Main is typically larger than some of your loops, or it could be the same size. The reason we talk about a loop is if you had a straight line distribution system, if somebody used air prior to the person on the end, they're robbing compressed air from them, and they may have a pressure drop and not be able to run their piece of equipment. If you have a loop, you can have air coming from either direction, meaning nobody's going to rob the air from you. It could come around the back side. So by air coming from 2 different directions, there's 2 things that happen. Number one, that nobody's going to rob that person of air. But number two, you've actually doubled the size of your airlines, or 1.5 size of your airlines. What I mean by that, it'll be less pressure drop because we've increased the amount of piping leading to any one point. So instead of, let's say, a 2-inch pipe, will actually now in a loop will act like a 3-inch header.
Yeah, and it makes sense because if you have one unit, you have a CAC on one end, you have a lathe on the other, and they both need it. Again, these are just examples. But if they're both running at the same time, they'd be able to, and anybody else that needs to use the air is able to do so.
Right.
And again, keep in mind that this is just a diagram, just as an example. It would most likely vary due to your application, but if you are looking to do something like this, let us know, and we'll be more than happy to help you out with that.
I'd like just to point out one more thing. You notice that all of our drops there are straight down. If your system is dry, you have a dryer system similar to this, and you haven't had over temperature in your compressor room that would create more moisture downstream, you want to know if you have a problem with your dryer right away. So in a loop like this, where you have your drops coming down, you're going to find out right away that you have an issue with water. If you have these drying off the top, for example, so you keep the water in the piping, you'd end up with a whole bunch of water in that system before you found out about it. And that's not probably a good situation. So we would like to, unlike previous theories about how you pipe something going up and over and down, we feel that you can come straight down from the pipe and still have a clean system, and finding out whether or not you have moisture immediately.
Now, moving forward, I mean, we do have, he mentioned air tanks, air storage, like the wet tank, the dry tank. Why are these a little bit more important than somebody else would think?
Well, a lot of companies have one tank, and that's not wrong. However, this is better, okay? Again, that wet tank will help you out with the burden on the dryer, and any drain problems that you might have in your compressor. Remember, 70% of that moisture comes from out of that air compressor. And if you don't drain it, it's going to end up someplace, and you'd rather have it in a wet tank than downstream into the dryer. So that's part of the reason for the wet tank. And obviously the dry tank is something that we'll talk about later in another segment of some sort, to give you some information on what would be the best sizing for a given system. But again, contact us. We can help you through the sizing of tanks.
Yeah. So here's another poll for you guys. What is the best piping materials for compressed air? I'll give you guys a minute just to be able to go ahead and answer them. All right. So let's see. Wow, I'm surprised. Everybody picked aluminum. Usually it's the other way around, but you guys are correct. Now let's find out why.
Well, first I saw somebody pick PVC. Let's start there. That's a definite no-no, okay? People have been killed using PVC pipe, and you want to get rid of that. You can look in the websites, government websites, and find out what kind of damage it has done to, in the industry as far as PVC piping is concerned. So I am cautioning you, get rid of it, go to something else. I don't care what you go to, but don't have PVC. Okay. First we'll talk about black iron pipe. Black iron pipe will rust. Also, it's inexpensive, but it takes a lot of labor to put it in. You have to cut it the length. You have to make sure the lengths are right. You have to thread the pipe, all that kind of thing that goes into to assembling black iron pipe. And not only that, but as it corrodes, it becomes more friction, and you have pressure drop through that. Galvanized pipe is much less likely to rust. However, it can flake off. And again, they get the same issues, threading the pipe, cutting to the length. Copper pipe, you have to cut at the length. You buy fittings, whether it be soldered, which takes a little bit of time, or you have ProPress, something like that, and then those fittings are very expensive. So copper in itself the material itself is very expensive also. Stainless steel, in most cases, stainless steel is dictated in pharmaceutical and food industry. It's very costly, but you don't have much choice. And again, ABS plastic, not a total fan of it. You can use it, but never, as it says, PVC. There have been people, and I had testified in a case where somebody died. So let's move on from here.
But we do offer the aluminum piping as an option. It's cost effective. It will not rust. It will not corrode. It's a lot lighter than other options. It does come in different sizes. It does allow you to be able to reuse fittings, whereas, for example, in the copper fittings, you would not be able to reuse them. You'd have to cut something else in length and just create new fittings. You can reuse these fittings, and it does allow you to be able to do some changes on the fly. If you have to add a new unit later on, you'd be able to do that without any problem whatsoever. It's a lot easier to do that with aluminum piping than it is with any of the others.
Yes, and aluminum piping there's other manufacturers, but the advantage of this one is that it has all metal fittings. They're not plastic. And that leaves it, allows it to be more stable with respect to leaks. We put this pipe up and we're done. We don't have any leaks. We use some of the other with plastic fittings. You put that up, and you still have to go around and make sure that that we don't have the leaks that we would have. And we have leaks with plastic fittings. Let's put it that way. Again, it's so simple to put up. You put the two pieces together, you hand tighten it, and then you take a quarter turn on the nut, and you're done. But there is one other advantage, and I tend to like this. When you lay out your plant, lay out your loop, whatever it might be, you don't necessarily have to put a elbow in locations where you think you'll have a drop. What you can do is lay out your whole piping system. And once you put your equipment in place, you can tie into that with what we call a saddle branch. And what you put that branch onto the pipe, drill into it. Now you have your drop right there. So you don't have to guess where your equipment will be. You put them where your equipment is once it's been placed. And if you have a system already designed and already up, if you add another piece of equipment, you always can tap into that system extremely easily. You don't have to cut the pipe in half or anything like that. You just add one of these saddle clamps and you're in.
Sounds good. Now you mentioned pressure drops. Why are these important?
Well, we mentioned every 2 pounds of increased pressure in your plant is 1% of your energy. It is important that your piping system is designed properly so you minimize the amount of right elbows, T's, and items that could cause you some pressure drop. However, pressure drop brought some of those fittings because of that. One of the things you have to watch for excessive pressure drop in would be filters. We just talked about filters. But what happens when they get dirty? You should change them once a year. But if in fact you have a very dirty environment, foundry or something like that, you may find out that the filter gets blocked a lot sooner than 1 year. A pressure drop across them can be enormous. You could have a filter that's designed for a 1 pound pressure drop on it too, but when it's totally loaded, it could be as much as 5 or 10 pounds. We had one company not too long ago that once they took care of their problems with the pressure drop, they dropped off a whole compressor, 100 horsepower air compressor. So that's significant, okay? Undersizing dryers, we talked about dryers and how you have to oversize dryers and correction factor, but if the dryer is undersized, let's say you have a 250 CFM usage, but you got a 200 CFM dryer. Well, it's going to take more energy to get that flow through a 250 CFM through a 200 CFM dryer than it would if it was a 250 CFM dryer or a 25 CFM dryer, or maybe even a 500 CFM dryer, depending upon the temperature entering the dryer.
Now we do have a pressure drop calculator on our website. If you want to go ahead and check that out, definitely feel free to. if after that you still have questions, reach out and we'll be more than happy to help you out with that. So now we have everything. I'm drying it. I have it cleaned. I'm good, right? That's it. We don't have to worry about anything else.
Well, again, it's just future here. You do have to worry about your air compressor. You have to maintain it. There's things you need to do there. But let's talk about actual CFM usage and flows. We offer at Fluid-Aire, and so do other people, offer data logging. Data logging is important to have a baseline of what's going on in your facility, knowing how much air you're using today versus how much air you're using tomorrow. And why is the air increasing tomorrow versus today? Did we add equipment? We needed the air. Did we not add equipment? Do we have more leaks? Do we have our people out there using air inappropriately, not appropriately? On the other hand, having that baseline allows you to work from that point and whether or not the usages out there are really doing work for you as opposed to just being wasted air. The other thing we should mention is that you can, as a baseline, you can get yourself a flow meter. I think that's on the next slide. And how much air you're using. Again, if you're using more air and you have more equipment out there, that's good. Okay, you're making more widgets or whatever it might be. But if it's just wasted air, you want to know about it. If it's leaks, you want to know about it. So in the first slide, when we do one of those audits, we also come in and do some leak detection, and we get you to a baseline on your leakage, so that anything that may come up later as far as leakage is concerned, you'll see on that flow meter. So again, if you have not added equipment and your flow meter goes up, it's going somewhere. We got to find out where.
Now you mentioned leak detection. Why is this really so important?
Again, in pressure, we should talk about that along with it. Leak detection is very important. Leaks will leak again, as we said, the compressed air is very expensive. But if you have higher pressure in your plant and you run, let's say 125 versus 100 pounds, every leak that you have will leak more. So not only are you losing it because of compressed air, losing because of the energy it takes to increase that, but you're using more air because the area leak is leaking more air, which is leaking money too. Again, there are programs available at most of the power companies that allow you to get in and get these leaks taken care of.
Chicago actually has one through ComEd that we actually partner with to be able to provide that service for you guys. You do have to
beneficial to you, it's wasted. So you need to, again, that's the cost situation of running an air compressor. The other thing is that you should maintain your machine. A machine that's not well maintained could cost you a lot of money as far as energy is concerned also. Oil should be changed at least, it depends on the oil manufacturer or the oil that's in your machine. Some's 2,000, some are 4,000, some are 8,000. Make sure you maintain that oil after a year, by the way, on any oil, it should be changed because of the shelf life. But maintain it according to your book. Again, your filter should be changed. Your separator should be changed. Again, not only is it important with the efficiency of the machine and long life of the machine, but you have an extra incentive is that the manufacturers require you to do this if you're going to continue to be under their warranty. And most warranties will last 5 and some last as long as 10 years.
Just like if you had your car, you're going to drive it, you just bought your car, you're not gonna just walk around and use it, not walk around, but drive around with it without doing an oil change or anything for 5 years. You're gonna have to keep up with it. Even if you have a vehicle warranty, it's the same concept. But that being said, I mean, we just went over what you need to know. So you definitely need to know how much compressor you need. Please do not guess. If you are not sure, call a professional, call us. We'll be more happy to help you out with that. Understand just how clean and dry your air needs to be. Understand the best materials and strategy to distribute your air, and know how to be able to control those future costs. Again, if at any point you need help, call us and we'll be more happy to help you out, or call your local professional. At this point, I believe we have some questions, so let's see if we can go ahead and take care of them. Or no, we don't have any questions, then let's see if you have any.
Let's beg for some questions.
That's one way, I guess. Do
Must have done a pretty good job with it.
it looks like we did pretty good. Oh, here we
I
go.
have one question.
Yeah, so I would see a question here that if we had any recommendations on specific flow meters.
Yes, well, Fluid-Aire cells are a really cool one. I mean, it clamps onto the pipe and and you can read it locally, or you can remotely tie it into something. I think that meter, and I can't remember the price, but it's real reasonable. Do you
I
remember?
don't know off the top of my head how much it is, unfortunately. It'll be-
$600-700.
Yeah, about
So, and it's not that expensive. And if you want to, you look at how much energy you could waste. But, and if you had that flow meter, you would not be wasting.
So we have a couple questions. What's the convenience of air pressure regulators?
Well, air pressure regulators are point of use typically. There's also a what's called an IC or a expander that's placed right after that dry tank. That's kind of gone away. If you buy a variable speed air compressor, those types of regulation aren't needed any longer. But you need to regulate. There are some machines that need 100 PSI. There's some machines that need 90 PSI. There's some machines that need 60 PSI. So you need to have the regulators at those locations, as long as they're regulated at that point. But never run your piping system any higher than the needs of that, that largest PSI usage. For example, if you're the one machine uses 100 PSI and that's uses the most PSI, that's where you want your pressure to be. If you over pressurize your system, your leaks will leak more. And remember, your leaks aren't going to be in your piping for the most part, because they'll be fixed at the time you install. But it's going to be on the drops, on the quick disconnects, on the hoses, on the barb fittings. That's when you're going to find your leakage. And it may be a cylinder here or there. Again, variable speed machines just allow you to set your pressure by 1 pound at a time to have exactly the amount of pressure that you need downstream.
So there's another question here about mist eliminators versus SPE filtration. I think that we could probably do an entire day on that.
Well, you can, but I have my opinions. Some people don't agree with me. A mist eliminator is a very large device. It's a very expensive device. Unless the power company's going to pay for it, I personally don't think they are worth the money. That's my opinion. They are usually a 3 micron filter. And remember, I said I like to get my air as clean as possible, down to 0.01 micron. So you will need a filter after it anyway. So I think in most cases that it's just another place to spend money. And that's my opinion.
And another question here, when to use master controls?
Okay, I am assuming you're talking about a controller that's going to control all your air compressors. I'm not certain what that's about. But having a multiple compressors of even of different sizes, how do you choose which machine should be on at any given time? You have the wrong combination on. And these controllers allow you to do that. And if you think that you have air compressors that are running that don't need to be running, or you can't set your your pressures on your compressors to be to allow that to happen, then a master controller is probably something you should be looking at, especially when you have three beyond two air compressors. That becomes a little bit easier to manage with a master controller.
So Luis, you do have another question here as to how to set up the equipment in the compressor room, distance for the walls, how to pipe. I'll be very honest, that's a question that we could take all day just answering that.
Well, I don't know how much. Everybody asks for 3 feet around all your pieces of equipment, and we know that sometimes compressor rooms aren't that large. You need to maintain the machines. You need to look at where the filtration is. You need to know where the oil fill port is, that you can get to it, okay? And if there's something you can't get to, make sure you put unions in your piping so you can move the machine around at least on a weekend when you're not running. So it's important to maintain your machine. And the other thing about too small a compressor room, boy, they heat up in a hurry. And I've been in compressor rooms that you walk in, it's 120 degrees to start with. And it's baffles me that people are wondering why they have moisture downstream when the compressor room is that hot.
Or why the compressor's overheating.
Yeah, or why the compressor's overheating and shutting down. I mean, the end result is, as I said, 15-degree approach. If you got 120 degree room, you got 135 degree air temperature going out. That dryer of equal size can't handle it. It just can't handle that additional load.
All right. Do we have any other questions? There's two in the chat.
What's that?
Oh, the opinion on exhaust air oil separators.
Exhaust air oil separators. That must be downstream at a use point. I'm not sure what you mean here, but I think this is something that will maybe it's a muffler of some sort, and also oil collection. So if you have any oil coming out of let's say a cylinder or a gang of cylinders, and you're trying to reduce the noise level, not only that, but collect any liquid oil that might be coming out, if that's what you're talking about. They're available. I don't have a lot of information on it.
And there was a question that I skipped, unfortunately. What type of master controllers do you recommend? Going back to what we were.
Well, we do handle one here, and I can't remember the manufacturer right offhand, but it's a good one. I mean, it will manage. The biggest problem with installing these things is the installation of it. Now, the cost of the controllers aren't that expensive, but the wiring to and from all the machines and the distances, if you want, especially if you want to go to a remote location for monitoring. These are things that are available on that. So I would say contact us, let us help you out, and we will give you some options.
What ambient temperature do you recommend a compressor room to be?
As cool, but not freezing. As cool as you can, but not freezing.
Like 60 degrees.
Yeah, I would be, but you're not going to get a 60. If you can keep your compressor room at the temperature that the outside temperature is, and again, when you do build a compressor room, if you're starting the new plant, outside wall, outside wall, outside wall, outside wall. Because if you don't have an outside wall, you can't ventilate. It's tough to go through the roof. It's tough to go. The outside wall is very important. So, end result is the compressor room as cool as possible. Again, the cooler it is, the better your dryer will work, the better your machine will work. Your machine should be running in temperatures around 180 degrees. That's the oil temperature should be. The discharge temperature is going to be 15 degrees, again, above whatever that room temperature is. And as I mentioned before, 20 degrees above. So if you have a 105 degree room, you're going to have 120 degree air coming out. Your dryer's got to be twice the size.
And the last question, what's convenient stuff out? Air intake or exhaust? Which one would be more convenient?
The exhaust. But air intake should come in at the bottom so that you're drying air across the machine and then back out the top. Again, obviously heat rises, okay, which is a little bit easier in that respect. But if you're not drawing it in at the bottom, if you're not allowing that airflow to go across the machine, you're not doing any good. What you can do is short circuit. Let's just say you had the air intake above the air compressor and then your air exhaust above that. You end up taking all that intake air, going right off the exhaust and never cooling the air compressor. So if that's sitting in the corner of a room, the room could be cool, but the compressor could be running in 50-degree or 25-degree hotter temperature.
Well, thank you very much for all the questions and your time. If you have any further questions, feel free to reach out to us. We'll be more than happy to help you out in any way we can. Again, thank you very much for joining us, and hopefully we'll see you soon.